Okay, guys, for this next video, what I'm going to do is I'm going to tell you exactly what you need to be able to pass the test tomorrow. You need to study your types of reactions. You need to, without fail, be able to predict, what kind of reaction is this? Is it combustion? Is it single replacement, double replacement? And I'm going to give you a couple of quick hints here. Okay, if you have two things that are being added together, that are coming together, so you have one thing and another thing, and they come together to form a compound, which is those two things combined, this is always a synthesis reaction. Okay, so remember, you need one thing plus one other thing, and those need to be by themselves, like elements or polyatomic ions that are alone, that either have a positive and negative charge. So they come together and produce a compound. And if you have a single product and two reactants, you have a synthesis reaction. Okay. If you have a single compound and your products are two single products, so either polyatomics or elements, then you have a decomposition. And some of you guys call these decombustion. Please remember that it is decomposition. And that is the opposite of synthesis. These are the opposing reactions. So here you have it breaking up into a positive and a negative ion. And combustion always looks the same. And I don't want you to mistake it for this or one of the replacement reactions. Combustion is always a hydrocarbon, so C something H something, plus O2. Okay, so a combustion reaction doesn't even can't even be simplified the way a synthesis or decomp. It will always look exactly the same. It has a hydrocarbon and an oxygen, and your products are always CO2 and water, and that is combustion. So that should be the easiest, probably the easiest three to remember, and we'll take a look on our next page, and then we can see our decomposition or double replacement and single replacement reactions. Okay. So again, to be successful on the test tomorrow, we are studying our types of reactions. So types of chemical reactions. And the last two types of chemical reactions are single replacement, and we also refer to this as substitution, and then double replacement, also known as a precipitation reaction. Okay. So we have single replacement and double replacement. And of course, single replacement, you're going to have a two compounds. We're going to change the color here. We want... Okay, so I paused it while I did all of the drawings so that you didn't have to watch me drawing. So on single replacement, you have a positive and a negative ion. And then you have either a positive or negative ion that is single, that is by itself, thus the name single. So you have this one thing that's by itself. Now that can be a polyatomic ion, like nitrate. So just be aware that this might look like it's more than one element, but you've got to double check those polyatomics to make sure that this isn't actually a single ion. So this guy will come and replace the other positive or negative, depending on what he is, ion, and then you will end up with a single here at the end. And of course, I forgot to add in our single replacement here. One sec. Okay, and now we're back, and I forgot to add this single guy that was left out at the end. So anytime you have this single ion on either side, and it's not a combustion reaction, remember we could go back to our combustion reaction where your your elements are always the same. So if you do have a replacement reaction that is not including oxygen and a hydrocarbon, then you have a couple and a singlet left at the end. This is a substitution or single replacement reaction. Okay, a double replacement is a little different because you have a compound and then another compound, and at the end you end up with two compound reactants, or reactants on the left and products on the right. You have two products that are the combination of this positive with this negative and this positive with this negative. Okay, so you have swapped partners. So double replacement is a swap. Okay, now single replacement is also a swap, but it is a swap of only one of your ions. So single replacement swaps one and double replacement swaps two. So that is a way to keep your types of reactions straight. Okay, and the next thing that you're going to need to be successful on tomorrow's exam is to know your formulas. A lot of this is going to require practice, and that's why I gave you so many practice problems in your worksheet. And that is that you need to pay attention to your oxidation numbers. You need to know how to find the charge of an element. Like if I say aluminum, you should be able to tell me that this has a charge of +3. If I give you oxygen, you should be able to tell me that it's -2. And of course, you should know that from your periodic table. Remember that the column is going to tell you the oxidation number, but it goes in order from +1, then +2, then you skip the transition metals, +3, positive -4, -3, -2, -1. And of course, the noble gases are 0. If you cannot remember that, please go back to the naming ionic compounds from the first 6 weeks. If you go to the class website and scroll all the way down to the bottom, you'll see videos there that cover this material again. And so a lot of this is review, but if you don't know these oxidation numbers, you will struggle on the exam. Also, don't forget your polyatomic ions. I've told several of you guys already that when you see something like NO3, the first thing through your head isn't, oh, that's a nitrate ion, and it has a charge of -1. Then you need to study those polyatomics. I know that they are on your reference materials, but several of you are still struggling with recognizing a polyatomic when you see it, and it's causing problems in your defining types of reactions. So being successful on this means being successful on the exam. The other thing a lot of folks are struggling with are name to formula and formula to name, particularly on the elements that are where the symbol is not what you would have probably expected to be. Examples are sodium. People are still using S, which is sulfur, and potassium, which is K, and other elements like lead and tin, which might seem unusual to you. So you should be able to recognize some of these guys and be able to go from name to formula and formula to name without getting bogged down in the periodic table. This is really going to take practice, okay? The next thing that you're going to need to be successful on your test tomorrow is to be able to get subscripts right. And getting subscripts right, once you know that you have to put this element with this element, you need to be able to know how many of them you have. And that goes back to the oxidation numbers from the previous slide. And of course, knowing the oxidation numbers should make this very simple. If you know that your oxidation number for aluminum is +3 and your oxidation number for -2, your oxidation number for oxygen is -2, then remember that you can do the crisscross, okay? Now, one exception to this is if you have an element that has a charge of 4. So, for example, you have C, which could be +4 or -4, and then you have H, which is -1, okay? If you have and say you have 2 hydrogens and you're given that you have 2 hydrogens, and so you have a -2, you can't just put, oh shoot, stop. I'm sorry there, I had a glitch with my stylus and I can't go back and edit that right now. I don't have time. So if you have, I'll go back. If you have a compound, say, oops, sorry, now I have an eraser. Now I have carbon, which is +4, and then I have something like an oxygen, which is a -2. If I do a cross multiply here, okay, and I get C2O4, this should, of course, be reduced to something like carbon dioxide, which is a more recognizable molecule because this is carbon dioxide, this is not carbon dioxide. So if you have 2 even charges, you need to make sure that you do reduce those to get yourself an empirical formula for the compound. So with AlO3, you should be able to know how you get that. Magnesium oxide, of course, magnesium has a +2 charge and oxygen has a -2 charge. And if you cross multiply here or bow tie here, you get Mg2O2, which you should reduce to be MgO, right? So a 2 charge and a +2 charge and a -2 charge equal out, so you only need 1 magnesium and 1 oxygen, okay? Here you have Ca and Cl and Na and Cl. So how can you tell which of these is going to need what subscripts? And of course you use your oxidation numbers again. With calcium you have a +2 and a -1 charge. So you need 1 calcium and 2 chlorines. And for NaCl you have +1 and -1. So NaCl simply has 1 sodium and 1 chlorine atom. Okay, so you should be able to work those. And if you're struggling with that, please take a couple of random elements, take a metal and a non-metal from the periodic table, and practice putting those together in a compound. Okay, and the last thing that you need to be successful on the test tomorrow is one of the last things, you've got one more thing, balancing equations, and that is to count your atoms on each side of the equation, compare to see if they're equal, change your coefficients if they are not, and check your answer. Okay, I think some of you are forgetting this last step, and you're not really checking because you're making some silly mistakes. So please make sure that you do count, compare, change, and check. And then, of course, you need to go back and repeat because this is a trial and error sort of process. So it is trial and error, and I know that some of you are going nuts over the whole error part of this, but go back and fix it until you get equal numbers of all atoms on both sides. Remember that there is no partial credit on balancing equation problems because either your equation is balanced or it's not. There's no, I got 3 of the numbers right, but not this one. If your equation is out of balance, it's out of balance, period. So I can't offer extra credit on those problems. Okay, for this next slide, we're going to be looking at the final thing you need to be successful on your test tomorrow, and that is metal activity. And this is whether or not a single replacement reaction is going to occur. We have an entire video on this if you need to review it, but what it basically boils down to is asking, is this reaction going to occur? And so, of course, here you have our metals, lithium and aluminum. Now, is aluminum going to come in and replace lithium? And in this case, the answer is no, because if you look at your metal activity chart, which has metal activity with the highest active metals on the top and in decreasing order of activity, if lithium comes before aluminum, lithium is not going to be replaced by something that is lower on that activity chart. So please make sure that you do know how to read the metal activity chart and use it to predict whether or not a reaction will occur. If you are successful and you know how to do each of these things, then please study them and be ready for the test tomorrow. If you're still struggling with any one of these things, please get with someone in the class that does know how to answer these questions and help each other out. I will be giving a reward for the class who has the highest average on the exam tomorrow. I will be doing an aluminum replacement reaction with a very strong hydrochloric acid, which makes a huge, ginormous boom. I have all of the supplies and I have the approval to go do it. So make sure that you guys have the class with the highest average and we'll go explode something. All right. Have a great day, and I'm very sorry that I couldn't be there today, guys. I'll be back tomorrow. Keep your fingers crossed.